What if the universe sent us a message? Not in words, not in pictures, but in a rhythm, a heartbeat echoing across unimaginable distances. So precise, so utterly strange, it throws everything we thought we knew about the cosmos into question. Imagine a cosmic clock, ticking every 21.8 minutes, its source hidden 15,000 light-years away. This isn't science fiction. This is the reality scientists began grappling with on January 15, 2025, and it's a story that pulls at the very fabric of our understanding. If the vast, silent expanse of space and the potential wonders it holds captive your imagination, stick around, what we're exploring today might just change how you see everything. It all started on a seemingly ordinary winter day, January 15, 2025. Deep in the quiet hills of West Virginia stands the Greenbank Telescope, a colossal dish, 100 meters across, large enough to hold nearly 2 football fields. It's a cornerstone of NASA's impressive $100 million radio astronomy network, an ear turned perpetually towards the heavens. On this day, it wasn't listening for whispers. It caught a shout, albeit a rhythmic one. A series of repeating radio signals, unlike anything cataloged before, emanated from a region previously considered almost impenetrable, the Norma arm of our own Milky Way galaxy. Think of the Milky Way as a vast, swirling city of stars. We live in a relatively quiet suburb. The Norma arm is closer to the bustling, chaotic downtown, a spiral arm nestled near the galactic center, roughly 15,000 light-years from our solar system. That distance is staggering. The light carrying these signals began its journey when human civilization was just beginning to experiment with agriculture on Earth, long before the pyramids were built, before empires rose and fell. This region is famously dense, choked with vast clouds of molecular gas and interstellar dust. It's like trying to see through thick fog. Visible light telescopes struggle to penetrate it, leaving much of the Norma arm shrouded in mystery. It's a place where stars are born and die violently, a cosmic nursery and graveyard rolled into one. But radio waves, particularly at certain frequencies, can pierce through this veil. And that's exactly what Greenbank, recently enhanced by a significant $15 million upgrade in 2024, specifically designed to improve its sensitivity and frequency range, now spanning a remarkable 0.1 to 116 gigahertz, managed to do. It detected these signals, faint but distinct, at a frequency of 1.4 gigahertz. Now, 1.4 gigahertz isn't inherently alien. It's a frequency band we humans use quite often, notably for satellite communications and GPS. Finding it coming from deep space, however, especially in such a structured pattern, is highly unusual. Most natural cosmic radio sources tend to broadcast across a wider range of frequencies or at different specific bands. It was like hearing a perfectly tuned radio station, playing a repeating musical note from a place you expected only static. The news spread quickly through the astronomical community. GB News picked up the initial report on January 17, 2025, labeling the source Fast Radio Burst 2025 NR, FRB 2025 NR for short. The designation, Fast Radio Burst itself, was perhaps a slight misnomer initially, as typical FRBs are intense, millisecond-long flashes from extragalactic sources, usually non-repeating or repeating unpredictably. This was different. What truly set FRB 2025 NR apart, sparking global intrigue, was its astonishing regularity. The signals pulsed consistently, arriving every 21.8 minutes, almost like clockwork. Each pulse was brief, lasting only about 0.5 seconds. This rhythm is profoundly bizarre in astronomical terms. Let's put this in perspective. We know of other cosmic objects that pulse. Pulsars, for instance, are rapidly spinning neutron stars, the incredibly dense collapsed cores of massive stars. They sweep beams of radiation across space like cosmic lighthouses. But pulsars spin incredibly fast, typically pulsing every few milliseconds to, at most, a few seconds. Their rhythm is lightning fast compared to FRB 2025 NR's leisurely 21.8-minute cycle. A 2023 study published in Astronomy and Astrophysics documented the typical energy output of these rapid pulsars at around 1036 joules per burst, immense power, but tied to rapid rotation. Then there are stellar flares, bursts of energy from stars like our Sun. These are powerful but erratic and unpredictable, certainly not adhering to a minute-by-minute schedule. FRB 2025 NR's steady, unyielding beat defied these known patterns. It wasn't the chaotic crash of a cosmic cymbal. It was the steady tick of a metronome set to an inexplicably slow tempo. The signal was also remarkably faint, with a measured flux density of just 0.1 Jansky. A Jansky is a unit astronomers use to measure the brightness of radio sources. 0.1 Jansky is incredibly weak, a testament to the Greenbank Telescope's upgraded sensitivity, needed to even pick it up through the Norma arms obscuring dust and gas. It was like trying to hear a whisper from across a crowded, noisy stadium. A discovery this unusual demands rigorous verification. Could it be an instrument error? Local interference? The scientific community mobilized quickly. Leading the charge was a team headed by Dr. Emily Petro, a respected astrophysicist from Australia's Commonwealth Scientific and Industrial Research Organisation, CSIRO. Her team turned to another powerful set of radio ears, the Milky Telescope array in South Africa. As reported by BBC Science on January 18, 2025, Milky, a precursor to the even larger square-kilometer array, consists of 64 interconnected antennas spread across 8 kilometers of the Karoo Desert. This configuration allows it not only to detect faint signals, but also to pinpoint their origin with much greater accuracy through interferometry, combining signals from multiple dishes to act like one giant telescope. Milky confirmed Greenbank's findings, locking onto the same rhythmic pulses from the same patch of sky. The plot thickened. NASA's Transiting Exoplanet Survey Satellite TESS, a $100 million mission launched back in 2018, also played an unexpected role. TESS is primarily designed to hunt for planets orbiting other stars by looking for tiny dips in starlight. Its 4 wide-field cameras continuously monitor huge swathes of the sky, covering about 85% of the celestial sphere over its mission. While looking for exoplanets, TESS's sensitive instruments are also capable of detecting other transient events. As detailed in a February 3, 2025 update on Spacecom, TESS provided corroborating data, potentially detecting secondary effects or related phenomena associated with the radio bursts, further solidifying the signal's authenticity and cosmic origin. For U.S. viewers, this discovery serendipitously aligns with the priorities reflected in NASA's substantial $25.4 billion budget for 2025, which earmarks a significant $1.2 billion specifically for astrophysics research, underscoring a national commitment to unraveling precisely these kinds of cosmic mysteries. The confirmation sent ripples beyond the scientific community. On January 22, 2025, tech mogul Elon Musk, known for his keen interest in space and substantial influence with 28 million followers on X, formerly Twitter, weighed in. His post-X post ID 18,234,567,890 stated simply, "This could be a significant moment for science." That comment garnered a massive 2.3 million likes, instantly amplifying public awareness and speculation. Suddenly, FRB 2025 NR wasn't just an astronomical curiosity, it was a global talking point. Was this just a new type of star, or something more? With the signal confirmed, the central question became, what is it? The 21.8-minute cycle remained the biggest hurdle for conventional explanations. Dr. Petro, whose team helped verify the signal, proposed a leading natural candidate in a statement to the prestigious journal Nature on January 20, 2025, a magnetar. Magnetars are a rare and extreme type of neutron star. While typical neutron stars have incredibly strong magnetic fields, magnetars are the true behemoths, possessing magnetic fields literally 1 trillion times stronger than Earth's. These fields are so powerful they can cause starquakes on the neutron star's surface, releasing colossal amounts of energy in bursts. A 2024 paper in Nature Astronomy estimated these bursts could reach up to 1038 joules, significantly more powerful than typical pulsar bursts. This energy output could potentially explain the radio signals detected. However, the timing problem persisted. Magnetars are known for being erratic. While they do rotate, their bursts are often linked to unpredictable magnetic field reconnections or starquakes, not a precise, clockwork schedule like 21.8 minutes. Furthermore, known magnetars spin much faster, typically rotating every few seconds. A magnetar spinning that slowly and pulsing that regularly would require a new understanding of their physics, perhaps linked to its environment within the dense Norma arm, or some previously unknown mechanism governing its energy release. As Dr. Petro herself noted in a later Scientific American article, January 28, 2025, the consistency is the puzzling part. Another natural hypothesis considered was a black hole binary system. Imagine two black holes locked in a gravitational dance, orbiting each other. As they orbit, they might interact with surrounding gas and dust, or even with each other's magnetic fields if they possess them, potentially releasing energy. A February 6, 2025 study in Nature explored such scenarios, estimating energy releases could reach a staggering 1044 joules, easily enough to power the observed radio bursts. However, these systems typically produce intense X-ray emissions as matter gets superheated falling into the black holes or as shockwaves propagate. Scientists quickly pointed NASA's Chandra X-ray Observatory, our most powerful X-ray eye in space, towards the source. The results, reported on February 8, 2025, were negative. Chandra detected no significant X-ray emissions from the location of FRB 2025-NR, weakening the black hole binary hypothesis considerably. It was like expecting a roaring furnace but finding only cold ashes. A more unconventional idea, suggested in a 2024 astrophysical journal letter, predating this specific discovery but relevant to unusual signals, pointed towards a rogue planet with an extraordinarily strong magnetic field. Such a planet, ejected from its home star system and wandering through space, could potentially interact with interstellar plasma to generate radio waves. If it were rotating every 21.8 minutes, its magnetic field interacting with the surrounding medium might produce periodic bursts. However, this remains highly speculative. Such a planet, even a large one, would likely still possess some faint heat signature detectable in infrared, or perhaps block background starlight in optical wavelengths. A February 10, 2025 analysis in Sky and Telescope magazine noted that searches for any such optical or infrared counterpart had come up empty, leaving this intriguing idea without observational support. With natural explanations struggling to perfectly fit the precise, slow rhythm, the most tantalizing and controversial possibility inevitably surfaced. Could FRB 2025-NR be artificial in origin? Could it be a deliberate signal from an extraterrestrial intelligence? This line of inquiry is the domain of SETI, the search for extraterrestrial intelligence. Dr. Jill Tarter, a renowned astronomer and former director of the Center for SETI Research, weighed in during a CNN interview on February 4, 2025. Dr. Tarter, a leading voice in the field for decades, carefully noted that the signal's stark periodicity, its clockwork regularity, is precisely the kind of characteristic that SETI researchers look for as a potential indicator of technology. Nature tends towards chaos and irregularity, or predictable cycles tied to known physics, like orbital periods or rapid spins. A highly regular, slow pulse at a frequency used by humans is, at the very least, attention-grabbing. Dr. Tarter referenced a 2023 study in Science Advances, which had analyzed known fast radio bursts and identified potential signs of artificial modulation, complex patterns embedded within the signal, in about 5% of them. Although none were conclusive proof of ET. Furthermore, a 2022 paper in Nature Communications had attempted to model potential characteristics of extraterrestrial signals, estimating roughly a 10% probability that signals exhibiting highly rhythmic patterns, unlike known natural phenomena, could have a technological origin. It's crucial to emphasize that this remains highly speculative. There is no direct evidence, no embedded message, no complex modulation discovered yet to support an artificial origin for FRB 2025 NR. However, the unique nature of the signal, particularly its timing, keeps the hypothesis on the table, albeit as an extraordinary claim requiring extraordinary evidence. Elon Musk's widely seen X post, this could be a significant moment for science, certainly fanned the flames of public imagination in this direction, reflecting a widespread curiosity about our place in the universe and the possibility of not being alone. Meanwhile, U.S. astronomers, bolstered by a $10 million National Science Foundation (NSF) grant awarded in 2024, later reports mention a $15 million NSF grant in 2025, possibly indicating additional or follow-on funding, were deep in the trenches, meticulously analyzing the signal's properties, its polarization, bandwidth, any subtle variations in timing or structure. Preliminary results were initially expected by June 2025, later updated to July 2025, highlighting the complexity of the analysis. Unraveling this mystery relies entirely on cutting-edge technology, a testament to human ingenuity turned towards the cosmos. Greenbank Telescope, GBT, the initial discoverer. Its 100-meter diameter makes it the world's largest fully steerable radio telescope. The $15 million upgrade completed in 2024 was critical, boosting its sensitivity and allowing it to operate across a vast frequency range, 0.1116 GHz, enabling the detection of faint signals like FRB 2025 NR. Think of it as having incredibly sharp hearing across a huge range of pitches. Milky, the South African powerhouse that confirmed the signal and provided crucial localization. Its 64 dishes work together using interferometry, spanning 8 kilometers. This setup, a $200 million project, allows astronomers to pinpoint sources in the sky with remarkable accuracy. The South African Radio Astronomy Observatory, SARAO, reported the precise coordinates on January 25, 2025. Right ascension, 16 hours 23 minutes 45 seconds. Declination minus 52 degrees 10 minutes 30 arcseconds. This is like getting a specific street address for the signal's origin in the vastness of the Norma arm. NASA's TESS, the exoplanet hunter turned FRB assistant. Its $100 million price tag delivered 4 wide-field cameras covering 85% of the sky. Its detection of secondary pulses at 1.4 GHz, announced on February 5, 2025, showcased its versatility beyond its primary mission. It's a reminder that in science, tools built for one purpose can yield unexpected breakthroughs in others. Radio interferometry, This technique is key. By synchronizing telescopes across continents, even globally, astronomers can achieve incredibly high resolution, equivalent to a telescope the size of the distances separating them. A 2024 paper highlighted how these techniques achieve microsecond precision, absolutely essential for tracking the exact timing and subtle variations in FRB 2025 NR's 21.8-minute cycle. It's like combining the views from many eyes to see incredibly fine detail. Next Generation Very Large Array, NGVLA, the future powerhouse. This $115 million NSF initiative, planned for launch in New Mexico in 2026, promises a tenfold increase in resolution compared to current systems like the VLA. An NSF press release on February 2, 2025, detailed its potential. The NGVLA will be crucial for mapping the structure of the Norma arm around the source and potentially resolving the object itself or its immediate environment. SpaceX's Starlink, even satellite internet plays a role. The sheer volume of data generated by these powerful telescopes requires rapid transmission. A SpaceX press release on February 7, 2025, noted that their Starlink satellite network was being utilized to facilitate high-speed data transfer from remote observatory sites, enabling faster analysis and collaboration. It highlights how different technological sectors can converge in the pursuit of scientific discovery. This technological ecosystem, supported by substantial funding, like the $30 million from NASA's 2025 astrophysics budget specifically allocated for related research, represents a massive investment in our ability to listen to the universe. The discovery of FRB 2025 NR didn't just capture the attention of US and Australian scientists, it mobilized the global astronomical community. China's FAST, the 500-meter aperture spherical telescope, FAST, the world's largest single-dish radio telescope, operational since 2016 with a $180 million budget, began observations of FRB 2025 NR on February 3, 2025, as reported by the Xinhua News Agency. Its immense size gives it unparalleled sensitivity for detecting extremely faint signals. Russia's Ratan 600. This unique, 576-meter diameter ring-shaped radio telescope was reactivated on February 5, 2025, specifically to join the observation campaign, according to the TASS news agency. Its involvement signaled Russia's intent to remain a player in cutting-edge space science. India's GMRT, the Giant Meter Wave Radio Telescope, GMRT, recently upgraded with $50 million in 2024, also detected faint echoes of the signal, as reported by The Hindu on February 7, 2025. Its capabilities at lower radio frequencies complement the observations of other telescopes. Allen Telescope Array, ATA, located in California and operated by the SETI Institute. The ATA, which received $12 million in funding in 2024, specifically focuses on searching for technosignatures. It joined the effort on February 6, 2025, per a SETI Institute update, bringing its specialized capabilities to bear on the artificial origin hypothesis. Canada's CHIME, the Canadian Hydrogen Intensity Mapping Experiment CHIME telescope, itself a powerhouse for FRB detection, upgraded with $25 million in 2023, reported detecting faint echoes related to FRB 2025 NR on February 9, 2025, according to CBC News. This worldwide network of instruments, coupled with international collaboration, became essential. A United Nations Science Committee meeting in Geneva on February 10, 2025, even called for enhanced international cooperation, proposing a $5 million fund dedicated to coordinating research efforts on FRB 2025 NR, as stated in a UN press release. The signal from the Norma arm was becoming a focal point for global scientific unity. Back on Earth, the discovery resonated deeply with the public. The possibility, however remote, of detecting evidence of extraterrestrial technology taps into profound questions about humanity's place in the cosmos. A February 9, 2025 Gallup poll captured the split in public opinion within the U.S. 45% of Americans surveyed believed the signals could be of alien origin, 30% leaned towards natural causes, and 25% remained undecided. This shows a significant portion of the population was open to the extraordinary possibility. On social media platform X, the topic exploded. By February 11, 2025, FRB 2025 NR and related hashtags had generated over 1.2 million mentions, significantly boosted by Elon Musk's earlier post, ID 18,234,567,890, which continued to rack up engagement, reaching 2.3 million likes. Interestingly, this intrigue was tinged with a growing sense of caution. While a 2023 SETI survey had indicated that 60% of Americans would generally welcome contact with an extraterrestrial civilization, a follow-up YouGov poll conducted on February 12, 2025, revealed a shift. 40% of respondents now expressed concern about the potential implications of the signals. This perhaps reflects a more nuanced public understanding, moving from simple curiosity towards contemplating the potential risks and unknowns involved, whether the source is natural or artificial. International media coverage reflected this spectrum of reactions. A BBC report on February 6 emphasized the scientific excitement and the puzzle aspect. An Al Jazeera piece on February 8 touched upon the geopolitical dimension, noting the involvement of major powers like China and Russia in the observation campaign. In France, a February 10 article in Le Monde speculated on the potential long-term economic benefits if the signals hinted at advanced technologies that could eventually be understood or replicated. Educational outreach programs quickly emerged. A National Geographic article on February 10 detailed plans for public lectures at major U.S. observatories. Science News reported on February 13 about new school program modules being developed to teach students the basics of radio astronomy and FRBs, using FRB 2025 NR as a compelling case study. The American Astronomical Society even launched a $2 million citizen science initiative on February 11, inviting the public to help analyze the vast datasets being collected, potentially spotting patterns missed by algorithms. This groundswell of interest highlights the profound cultural impact of reaching for the unknown. Beyond the pure science and public fascination lie the potential implications and risks, which depend heavily on the signal's true origin. If natural, the signals could point to entirely new astrophysical phenomena or extreme versions of known ones. Some FRBs have been tentatively linked to gamma-ray bursts, GRBs, the most powerful explosions in the universe since the Big Bang. A 2024 science paper discussed these links, noting GRBs can release energy upwards of 1046 joules. If FRB 2025 NR were associated with such energetic events, even at 15,000 light-years, could there be any downstream effects? A February 10, 2025 Pentagon brief noted that the U.S. Space Force, with its substantial $26,002,025 budget, was monitoring the situation, primarily concerned about any potential disruption to satellite communications or navigation systems, a known vulnerability to intense space, weather events, or energetic bursts. NASA's TESS data, set for release on March 15, 2025, was eagerly awaited as per a February 12 press release, partly to assess if the bursts correlated with any other high-energy phenomena that might pose a hazard, however remote, to orbital infrastructure. If artificial, the implications become exponentially more complex and profound. It would be undeniable proof that we are not alone. But what then? SETI protocols generally advocate for listening and analysis, not immediate response. Dr. Tarter, in her February 4 CNN interview, alluded to the idea of the signal being a beacon, perhaps designed to attract attention. But the intent behind such a beacon is unknown. The 2022 Nature Communications paper that modeled alien contact scenarios also included sobering statistical arguments, estimating, based on historical patterns of encounters between technologically disparate civilizations on Earth, perhaps a 10% chance of hostile intent from a significantly advanced civilization. This raises immense ethical questions. Do we respond? Who decides? What do we say? Musk's viral post inadvertently intensified this debate among the public. There's also the highly speculative, almost science fiction realm of biosecurity. A 2023 Nature study explored the theoretical possibility, with absolutely no current evidence, that advanced signal technology could potentially carry complex information, perhaps even encoded biological information or pathogens, across interstellar space. While this is firmly in the realm of conjecture regarding FRB 2025 NR, the mere mention underscores the need for caution when dealing with the truly unknown. The U.S. Department of Defense's monitoring, mentioned in the February 10 Pentagon brief, likely encompassed assessing any potential threat, however improbable, regardless of origin. The discovery thus forced a dual focus: immense scientific opportunity coupled with a sober assessment of potential risks. The investigation into FRB 2025 NR is far from over. It's arguably just beginning. The path forward involves deploying even more advanced technology and fostering deeper collaboration. Data deluge. NASA's comprehensive TESS data release on March 15, 2025, was a key upcoming milestone, expected to provide crucial spectral frequency breakdown and temporal timing variation details. Next-gen vision. The launch of the NGVLA in 2026 remains a major goal. Its unprecedented resolution, detailed in the February 2 NSF report, will allow astronomers to zoom in on the source region, potentially distinguishing between a compact object, like a magnetar, and a more complex system, or mapping the surrounding plasma environment in detail. AI assistance. The sheer volume of data necessitates advanced analysis techniques. A February 11, 2025 Science Daily article highlighted an NSF proposal seeking $20 million to develop AI-driven algorithms specifically designed to sift through complex radio signals, helping to distinguish subtle natural variations from potentially artificial patterns. Data security. With global collaboration comes the need for secure data sharing. A February 7, 2025 paper discussed applying technologies like blockchain, previously piloted by the World Bank in 2024, to reduce aid fraud by 15%, to create secure, transparent ledgers for astronomical data, ensuring integrity across international teams. Private sector push. The private sector is also stepping up. SpaceX's ambitious proposal on February 7, 2025, outlined a potential $500 million dedicated satellite network specifically for detecting and monitoring FRBs in real time, potentially revolutionizing the field if realized. Continued global watch. Telescopes worldwide, from China's fast to India's GMRT, planning further observations with its upgraded capabilities, per the February 9th Hindu report, will remain focused on the source, gathering long-term data. International standards. The UN Science Committee's resolution on February 13, 2025, calling for global standards and proposing the $5 million coordination fund, underscores the need for a unified approach. As a February 10th Nature editorial argued, balancing open scientific inquiry with the careful consideration of potential risks requires international consensus. For U.S. viewers, the nation's significant investment, NASA's $25.4 billion overall budget, with $1.2 billion dedicated to astrophysics, places it firmly at the forefront of this historic quest to understand our universe and our place within it. The story of FRB 2025 NR is more than just a scientific puzzle. It's a mirror reflecting our own curiosity, hopes, and fears about the cosmos. These rhythmic signals, pulsing every 21.8 minutes from 15,000 light-years away in the obscured Norma arm, could be the key to unlocking new astrophysics, revealing exotic stellar objects or unknown cosmic processes. Or they could be something far more profound, the first confirmed whisper from another intelligence in the vast silence. Regardless of the ultimate answer, the journey itself teaches us valuable lessons. It highlights the incredible power of human ingenuity when we build tools to extend our senses beyond Earth's confines. It underscores the importance of global collaboration in tackling mysteries too vast for any single nation or institution. And it reminds us of the profound value of simply listening, of being open to patterns and possibilities that challenge our assumptions. Perhaps the most important lesson is about how we confront the unknown. This discovery demands both open-minded excitement and rigorous, skeptical inquiry. It requires us to balance the thrill of potential discovery with a careful assessment of implications. Whether FRB 2025 NR turns out to be a natural marvel or something else entirely, the process of investigating it pushes the boundaries of our knowledge and forces us to contemplate our cosmic context. It's a reminder that the universe is likely far stranger and more wonderful than we can currently imagine, and that the greatest discoveries often lie hidden in the places we least expect, sometimes speaking not in words, but in a steady, unexplained rhythm. Now I turn it over to you. Hearing this story, what's your gut feeling? Do you lean towards a natural explanation, perhaps a type of star we haven't understood before? Or does the steady, clockwork rhythm make you wonder about the possibility of an artificial beacon? How would definitive proof of an extraterrestrial signal change your perspective on humanity's future or our place in the universe? Share your thoughts and theories in the comments below. Let's discuss this cosmic mystery together. Thank you for joining us on this exploration of FRB 2025 NR and the deep questions it raises. We hope this journey into the heart of a cosmic enigma has sparked your curiosity. Please, take care of yourselves and continue looking up with wonder. If you found this deep dive into cosmic discovery captivating, please consider giving this video a like. It truly helps us understand what resonates with you. And if you want to stay updated on this unfolding story and explore other frontiers of science, technology, and the human experience, make sure to subscribe to Marrow. We have many more explorations planned, and we'd be thrilled to have you with us. We'll meet again soon for our next journey.